All right, let her rip.
All right. Well, welcome everybody to the Acoustic Guitar Builders Club. I am hosting today, just taking over for Max because he's going to be traveling soon. And I decided to run you through a couple times where I've had to make my own tools for guitar making and sometimes repair. And I got a couple different examples, some simple and some a little bit more complicated. So I just wanted to clarify that I'm focusing here on tools and not jigs. We could spend probably decades going through different jigs and fixtures, but this is specifically tools as in I'm making something to actually do the cutting or the machining, etc. So and simply the reason that I'm sometimes make my own tools is just out of necessity. Sometimes out of practicality. I want something right away that I don't have, or what I do have just isn't up to the task, and I feel I can improve upon it. And then sometimes there's just something that doesn't exist on the market, so I have to make it myself. So I'm going to share a screen. All right, everybody see a funny looking chisel?
I know I do.
Okay, thank you, Ian, for responding. So this was one of the first tools that I modified probably 20 plus years ago. This is a Sorby paring chisel. It has about a 8-inch or so handle, or excuse me, blade. And I wanted this tool specifically for carving braces. And
Michael, I think you changed window for seeing your Zoom browser.
Oh, okay. Let's see.
Best thing to do is to share your screen. Is your window still up? Yeah, there we go.
Okay. All right. Thanks for the heads up on that. Okay, so real quickly, this was a Sorby paring chisel with about an 8-inch straight blade, and I wanted a chisel specifically for brace carving on acoustic guitars, and having a bent blade at an angle, something like as shown, I find is much more advantageous for getting into the braces, tight spots, especially when a top is all braced up and you're trying to carve individual braces, and there's just not a lot of whole room to get around and get into the nooks and crannies. So this was nothing more than putting this end right here in a vise, heating this up with a little propane torch until it turned slightly red, and then just grabbing the handle and pulling it until I got a bend, and I just let it air cool. There was nothing more to it than that. Any changes in the hardness of the chisel was really just in this area, so I was staying away from the tip. So the chisel still sharpened fine and kept an edge just fine. So this was one of my first early attempts and successful attempts. And then more recently, I needed a couple of small edge tools that I could not really find on the market. And I wasn't sure, honestly, if I wanted to spend the money right away. But so I decided just to make them myself. And the whole process was a lot simpler than I could have imagined. So I decided to buy some 01 tool steel. And if you look around online, you'll get a lot of different recommendations about which steel to buy and why and where to get it. No, you should just use an old drill bits or files, etc. But I just wanted to be sure of the steel that I was using, since this was a new process for me. So I probably paid way too much for this, but I got this from McMaster Carr, and there's no doubt about its origin and what kind of steel it is. if you don't know what kind of steel it is, for example, if you just grab an old drill bit, then you might not know the proper way or the proper temperatures for the hardening and the tempering, etc. So this is the outside of the package, and right here, see if I can zoom in. Oops, yeah, it tells you not only what it is, but it tells you, okay, if we want to harden it, it's between 1450 and 1500. It's an oil quench, and actually that's what the O stands for, is oil. If you have for example, an A2 steel, A would mean air hardening. So, and then in the tempering, it gives you this temperature chart right here. And so you can, within a certain degree of specificity, you can control the Rockwell hardness by changing these temperatures for this duration of time. All right, and we'll go to the next slide. So this is really all that's needed, more or less. This is the O1 tool steel that was in that package I just showed you. And when I received it, it's in what's called a annealed or soft state. So it's probably got a Rockwell hardness of around 35. And so it's very easy to shape with files, hacksaw, sandpaper, grinder, you name it. And so just some basic hand tools, you can put this into any shape that you want. So I used a hacksaw to pre-shape the pieces and a file to kind of rough in the bevels and the angles that I wanted out of these edge tools. The other things you'll need are a torch, and I'm just using propane for this, but you can also use a MAP gas. You'll see these in your hardware stores. There would be a yellow canister, and those do burn at a hotter temperature. But for the size of the piece of steel that I was heating up, this was plenty hot, so no need for the MAP gas, and it is probably about twice the price of your standard propane torch. And then you need some oil. This is for the quenching. You can use, to my best understanding, you can use any oil. Some people recommend cooking oils because they smell nice. It's not like a gas station either. Peanut oil seems to be popular, or canola. And in this case, I just grabbed some oil I have for my compressor. So this is pneumatic oil. And so after a bit of shaping of the tools, this is the diagram to go from this annealed or dead soft state. And first we're going to harden. So we're going to follow this arrow, heat the tool up, or excuse me, heat the steel up with the propane torch into that 1500 range. And then we're going to quench it. And then we're going to temper it. And the reason that you want to temper it is once it's in this very hard state, it's probably Rockwell 65 ish or more, which could be fine, but it's also very brittle. So the steel would have absolutely no kind of toughness or resistance to any kind of impact or prying. A good example would be a drill bit. You would want the tip to be very hard, but the shaft that actually goes in the chuck, you would want to have a little bit of flexibility. Otherwise, you'd be breaking your drill bits all the time. And
we're having a technical difficulty with Michael Bashkin.
Yep. Hi everyone. Sorry. And Mike offered to step in while he gets reconnected. In tool making, I was going to show you this thing, which you guys probably have seen already on a few posts and things. Ian, do you want to pin me instead of you?
Yeah, 1 second.
That might work better. So again, like Mike was saying, not really jigs and stuff, but tools to do a specific task, and maybe something that doesn't exist, and you end up imagining something. And with 3D printing, is really easy to prototype stuff, and then maybe from there you can get to a more defined product. And this is the hold on, I don't have it here. This is that tang jig remover that's been posted on the Looth prints, also known as the untangler. This is like the first iteration where you basically chuck it onto a Dremel with a cutoff wheel, and the ramp guides the fret to cut underneath the crown after you've clipped off the tang. And so it needed to slide up and down, and so there's a little dovetail. There is a lock-in thing. This works for Proxen. And then there was the screw-on Dremel version. But then there's all tools, especially like if you're printing stuff. It evolved as a prototype into something with an adjustment. So there's actually a rack and pinion that can help with the fine adjustment. And then we tried to figure out if it was possible to make it a more professional sort of tool. Because
Hey, sorry about that. I'm lost. I'm back. Anyway, Max, if I don't know if you want me to pick back up where I left off, or you just want to keep going.
Mine is just super quick. So if you don't mind, I can just like finish off and then you can continue.
Yeah, let's just get it out of the way.
Yeah. And so because this thing is all 3D printed, it was actually Buck was like, oh, I sent it, to get metal 3D printer. So like, oh, that could be interesting. And so a few iterations to figure out the tolerances and where to get it and all that. And now you have, well, this is not even the final product, because that those are packed already for tomorrow. But same concept with the adjusting, and then the lock thing. Actually, the final one has a little bigger knob here in the back, so it's easier to adjust. And the threaded base for the Dremel. But what's nice about this is that the fret does get a little bit hot while you're working, and if you're really cutting, which you shouldn't really do, because like the nib is very small, but like if you're a bit heavy-handed, it could get really hot and it could end up melting the plastic one. And so this, of course, doesn't melt, and it acts as a heat sink. So while the fret is on the ramp, it'll cool off basically, so you don't end up having. And so when you're working on it, if you feel like the fret is hot, then you're really taking too big a cut. The other advantage of the metal part compared to the plastic one is that the top, I don't know if you can see it, I polish it so the fret slides very nicely on the groove, whereas on the printed one you do have the little bit of ridges, which then kind of polish out with use a little bit, but it's not nearly as smooth as with the metal one. And then the other thing that was pretty cool was that sort of by accident, is that the tool actually, if you adjust it low enough, that you end up hitting the bottom of the wheel. So let me see if I have the wheel here. I can show you. So I am not mounting on the thing, but so let's say this is the wheel, right? Can you guys see it? So that's the wheel. Usually you're working like this, and so the fret gets caught underneath to clean up the tang. But if you adjust it so that this hits the bottom of the wheel, you can actually bevel the end of the fret, which will not be perfect with what then you have on the fretboard, but you can get close enough. So if you can adjust your nipper to have exactly, let's say 2 millimeters or 2.5, and then you cut your frets at the right length. Once you then, do the pre-beveling, once you install the fret, there's very little. You don't even have to cut the frets on the fretboard. You just need to file it a little bit, and and that was the tool. The plastic one without the adjustment, and both the bases, so both the screw-on Dremel compatible base and the pinch Proxen base are on the Looth prints. If you guys have a printer, or if you know somebody that can print it for you, it makes sure that when you print it like this. You want the sliding part to print laying down on this side so that the dovetail prints properly and the ramp is okay. This also gets printed standing up. And then the one thing you have to do is just chase the threads a little bit, because they are printed, but they're so small, they're not going to work. If you want the pro version, the metal one, it is, well, I did a batch. It just takes forever to hand fit the stuff, so I can't do too many at a time. And I might still have a few, but I'm taking a bunch to Artisan Show. So if anybody shows up there, I'll have a few. And if not, you can just get it on the website and I'll make more. And that's it. Back to Mike.
Wait, was that a sales pitch?
Also,
The sales pitch was like a half a second long.
it was a short, high pitch.
Do you have the ability to show that thing in action right now?
Oh, hey, Dan. Artisan, I'm leaving tomorrow. See you there.
You'll see him there. All right. Back to Michael.
All right. Thank you, Max. Okay. Sorry, I was rudely interrupted by my computer, and then when I turned it back on, it decided that it needed to update. Of course. All right. Let me just pull the album back up here. Okay. All right. So I believe we were on this diagram. I'm not quite sure when I was cut off. Okay.
Start from scratch on this.
On this diagram?
Yeah.
Okay. All right. So when I bought the 012 steel, it comes in an annealed, or in this diagram, it's called a dead soft state. It's about a Rockwell hardness of 35, and it's very easy to work with files, hacksaw, grinders. It's very soft. And then you need to harden it. And so we're going to bring it up to that temperature of the 1450 to 1500 degrees, and we'll do that with a propane torch. And in this state, it is very hard, probably Rockwell 65 or harder, but it's also very brittle, and the tool is prone to snapping, breaking, chipping. So you want to do one more process called tempering, which is to heat the tool at a low heat. And depending on how hard you want to try and leave the tool, that temperature will vary a bit. And I'll go through that in a minute. A couple more points I wanted to point out. As you can see, these arrows, some of them go both ways. So, for example, after you harden it, if you can then go back to annealing it, or even after you temper it, you can then just reheat it back to the 1500 degrees, and you will reestablish the hardness of it. What's happening in this state, at least with the O1 steel, and I'm speaking, or I'm really just parroting some of my bit of research on this. I'm not an expert at all, but as you heat it up, the carbon atoms basically fuse into the iron matrix. A different mineral of iron is produced that I forgot the name of. And you want to try and keep it in this state, which is why you quench it and you lower the temperature very quickly. Because as the temperature starts dropping, those carbon atoms start moving, and you start losing your Rockwell hardness. So the tempering can be done a couple different ways. I opted to use just a toaster oven, but you can also do it with a propane torch. There's a little bit more finesse involved, but it's very quick. In the toaster oven, you need to let it go for about an hour, whereas if you use it with a propane torch, which I'll talk about in a minute, you could do it, in probably less than a minute. So, and all right, let me move this over here. I'll go to the next slide. Okay, so these were the three edge tools that I wanted to make. One was essentially a skew chisel. This is a chisel of a very specific width, and this was one I was trying to make. It was a little bit of an experiment. I guess I would call it a wedger or a wedgie. It's got bevels on both sides, and I was trying to make a certain imprint on wood with it. So these pieces were all just cut out with a hacksaw from that bar that I showed in the earlier photo. These bevels were shaped with a file right here, and then I went straight into the hardening. So here's the propane torch. So general rule of thumb is when the tip of the tool turns cherry red, you just want to hold it there for, less than a minute, but probably more than 30 seconds. And that's just to make sure that the steel is heated evenly. And you can see over here, there's some different color bands going on, and these actually represent some different temperatures. Down here, you can see it's really hard to see in this photo. You just have to take my word for it, but it gets to kind of a yellowish brown, and that would indicate the color we want to try and achieve with the tempering. So when we get up to this, you want to have your oil very close by, and you can just very quickly touch this to the tip of your tongue just to make sure it's hot enough. And then you want to go right into the oil. And here I am going in the oil. Just a little, tip is you want to keep it moving. For a small, long piece like this, you want to go up and down. And that's because bubbles form on the surface. And you want to try and, which prevents the oil from contacting the steel evenly. And so you might get some temper differentials on the tool, and which may vary the Rockwell hardness a little bit in that area. So you kind of want to keep it moving and keep the bubbles off. And then, oops, I don't have a picture of the toaster oven, but so then you pop that blade in a toaster oven at 400 degrees for an hour, and then you're just ready to go ahead and sharpen it. The other way that I was going to mention to do the tempering is you can take your tool and, for example, heat this end of the tool, not the cutting edge, right here, and you want to watch the heat travel up the tool, and you'll be watching the colors actually travel along the length of the tool. And when you get to that yellow-ish, slightly brownish color on the tip, that's when you've reached the 400 degrees, and you want to stop right there, and the tool will be tempered, and you're ready to do your sharpening. And in this case, this was one of the specific cases, working on some kind of wood lace inlay, and I just needed some very small chisels, and then to make these cuts is what I wanted that the skew chisel for. So it was this was really easy, quick. For me, it was fun, and I would recommend, if anybody needs an edge tool, um, think about whether you can make it yourself. I'd say, I can get from that piece of bar stock to this if I wasn't using the toaster oven, I could probably get there in about 15 minutes. So you have a lot of instant feedback and satisfaction with this methodology. There's a lot of different types of steels out there. I only mentioned two of them. Those are just the two that I'm used to working with, the A2 and the O1. Knife makers could tell you a lot more about different types of steels than I could. So I should comment that Lee Nielsen, all of their blades, I believe, are A2 to the best of my knowledge. And O1 has the reputation of having a little bit finer crystalline structure, so maybe you can get a little bit of a better edge out of it. All right. Any questions on that? All right. The next tool I want to talk about that I made in the shop, actually, I didn't make it. James Rodman made it, but I designed it, and I just kind of want to run you through the thought process and some of the steps of making it. But this is the gramil that was available from LMI, rest in peace. And not that they went out of business because of this, but I can tell you that I really didn't like this tool. There was just way too many shortcomings and design flaws, I felt, for this to be really useful. It worked, but it didn't work that well. And I thought with some design changes, it could be a lot better. So one of the things I didn't like about it was that this was the blade that came with the tool. And, it's an inch long, maybe on a windy day. And it's really hard to sharpen because there's just not much to grab onto. And for those of you who have used gramils, if the blade isn't incredibly sharp, then you're really just wasting your time and probably creating more problems than you're trying to solve. The other thing I didn't like about it was this was how the blade was secured. There's a very large Allen wrench and socket head right here, which presses the blade against this part of the blade beam. And so you have these edges right here. And I found that at least on spruce, no matter how much I sort of relieved and polished these edges, it was always leaving a little bit of a mark, which I was really unhappy with. Other things were that the blade could twist at an angle in the slot. It was very hard to adjust the depth of it. And it was also very hard to adjust the width of the cut. There is an Allen socket head up here, and it presses down on the beam, which stops it from moving in and out. But there's no fine adjustment at all. So I decided that I was going to make some design changes to this and to see if I could make one that worked better. The first thing I did was I took this to a machinist, and on this side, can't really see it, but I had the machinist cut a slot for the blade where it could only slide up and down. It couldn't move at an angle back and forth. And then there was a small threaded tap that was put right in here. That was right in the face, but it was small enough that you still had a solid surface. And this is what indexes on the plates of the guitar or the side. So we weren't going to get any marks like you were prone to getting with this type of issue or setup. So the first thing I did was I drew it all out, and I had a professional CAD guy, person, uh, individual, could be a woman, but in this case it was a man, draw it up for me so I could submit this to a machinist. So this was all done, uh, as accurately as possible, where I probably could have sent this or taken this to any machinist and they could just work off the drawings. Um, Also made some changes in dimensions in that the beam holder itself was quite a bit longer and had a little bit more heft to it. And then I ended up working with James, who you all know, on this project. And these are some pictures that James sent me. If he's on here, he can certainly hop on. But he started with this raw brass stock and first cut it to length. And then these pieces, this is a piece of brass right here. It was secured in this holder with these Allen screws and then turned on just one face. So one face was convex, the other was flat. And after a few other steps, this was essentially what the beam looked like. The area where the Allen screws were to hold it into the last fixture are cut off at this point. And we have been selling these, so we got in, or James got into production on these. And then this is the beam holder. And the other modification I made was I have two different blade types. One is a 16th inch blade, and then one is a full 1/8 inch blade. And these holes were broach cut. So again, the blades don't really move around too much in these holes. And then this 1/8 inch blade is meant to be really kind of shaped by the user. You could use it as a scraper. You could reduce the width of it and just use it for a variety of different things. I know a few repair folks have used this to, for example, scrape the binding off of the old Gretches where it's falling apart, and this will clean up the channel very well. And you can clean up both the side and the bottom of the channel at the same time and keep them perpendicular to each other. And these are the tools all kind of set up, ready to get boxed. And then this is the final tool, all nice and polished out. The other thing that I felt the old gramil was really kind of lacking was any kind of control on the width of the cut. So these two set screws were put in here, and you can use this. You advance it out and it backs up right against the blade. And a quarter turn of this is about 2.5, 3/1000ths. So you can fairly easily, adjust the blade very precisely, within a thousandths or two at a time, just by using these set screws. And if you're wondering why there's one on this side, is because in some cases you want to index off of this long side of the beam holder, and sometimes you want to index off of this short side. And then this set screw just locks the beam in place forward and back. And here's the set screw for the front. And this whole thing is made to be flipped 180 degrees. So you can cut on this side. And on this side, what I do is I just took a file. This is brass. It's fairly soft. And just filed in an angle right here. And I would use this on backs. So this angle, filing an angle in here, overcomes the arch of the back. that is common on most guitars. So you get a more precise indexing off of the blade beam. And then finally, this was all James's idea, but he has this tool blade sharpener, and the as I mentioned earlier, one of the things I really didn't like about the first design was that the blade was about an inch long, very hard to sharpen, and with this sharpening jig, you can really maintain your angles very nicely, very easily, and repeatably. And this was the double bevel blade, but it also comes with a right hand and a left hand. In which case, you would just use either one of these slots. So, and I'm going to throw in a little bit of 3D printing, but James printed all these 3D boxes to hold the four blades and the tool sharpener. So those have been some of my experiences with making specialized cutting tools for guitars. I've got a couple other ideas, especially now that I know how easy it is to work and harden and temper tool steel. And at this point, I don't own a mill or a lathe, but again, if you get the steel in an annealed state, then it's very easy to work just with hand tools, especially if you're just making one-offs. So are there any questions, or does anybody have any tools that they would like to share? This is a club after all.
Hey, Michael, this is Mike Minton. I probably a year ago, I tried to coordinate with you on getting one of those tools from James, and I guess he was in between batches. Do you know if he has any right now? Because
I'm here. I don't at the moment.
Yeah. Are you going to make another batch?
I have to talk to Michael about that. I mean, I'm open to it. Unfortunately, time has been hard to come by recently.
Well, you can put me on a list of if you'll make one.
Okay, I do have you on a list, and we decided, given James's time commitments, and he has other projects in mind, that was just going to hold off making another batch. But if it happens, I will certainly let you know.
Well, you can't tease us like that and then say you're not going to do it.
Well, hopefully I've given you all of the incentive to just go ahead and make your own now.
That's right. This is about you learning how to make yours. Like James, would you take time to walk people through your process if you're not going to actively pursue it, or I mean, not now?
Right. Yeah, I mean, that would be up to Michael. I mean, I don't know how he feels about how detailed you want to be about sharing those designs.
What's that?
Yeah, I'd be fine with it. I think it's probably not an easy tool to make unless you at least have the mill and the lathe. And even then, I'm not sure.
Yeah, I mean, there's definitely, I use in the later batches, I use the CNC for some of those things. And I think there's some interesting processes in there, particularly the broaching of the rectangular holes that took some figuring out. Yeah, I'd be happy to do a run through of that.
So who else is taking that steel and hardening it and tempering it and stuff? James, that's how you're doing was that how you were making the Looth Saber chisel blades? Oh, anybody hear me? Michael, can you hear me?
I can hear you. Yeah, I think I can answer that for you. I know that James bought a furnace, which is kind of like the the real thing that you could be using besides a propane torch, because you can just tell it what temperature to heat up to. And I don't know how much it costs to get into the furnaces, but I think I've seen a few floating around used, and probably on the low end, they're at least a couple $100 for a half decent one, and probably at least twice that for a half decent new one of a small size.
Where are you at with interest in casting? Do you have any interest in casting?
Are you asking me?
Yep.
Oh, I have to tell you, I've got being pulled too many different directions all the time. So I'd love to learn more about casting and get into it, but right now, something like that, as fun as it might be, is not going to pay my shop rent. So,
what about you, James? You ever get into casting?
I never have, aside from a high school shop class.
Is that something with your fancy furnace you could think about doing? Like,
yeah, I think certain metals you could get hot enough, and I think brass and aluminum. I think you could do it with a torch. It would be interesting to pursue it. It's not something that I know anything about. I was going to talk about, talk about the hardness of the steel, and I think going through that process with the torch, you can be pretty confident that you've gotten pretty close to what the hardness you're looking for. But if you want a way of really determining whether you've reached your goal or not, you can get. I'll see if I can show these here. These are a set of files that are hardened to specific numbers, and what you can do is use the file and that's associated with the hardness that you're going for. And if it cuts, that the material you hardened is softer than the file is rated. But if it skates off it, you know that you've reached the hardness that you're going for. And these are about $60 online, so that's a pretty inexpensive way if you actually want to test how hard you've gotten. An actual Rockwell hardness tester is kind of a big, fairly expensive machine. It uses a diamond point to impress into the metal at a certain weight, and it measures how far it impresses in, and that's what gives you your Rockwell scale reading.
You have one of those, right?
I do. And if you like going down rabbit holes, then doing an internet search for hardness, Rockwell hardness testing, it's a pretty fun rabbit hole.
James, how much of a difference do you think it makes if, for example, I'm making an edge tool to cut wood, if it's 59 versus 60 versus 62? On the user's end, would I really notice any difference in performance or sharpening, or is it kind of splitting hairs at that point?
Hard to say. I mean, I think if you got down into the upper 50s, you'd notice that you need to resharpen more frequently. I think it would just be a matter of how much use. I mean, we were always, and everything I've read, shooting for 62, 63 is sort of the sweet spot for a lot of chisels. I think Japanese chisels sometimes have a laminated blade, and they'll get up 64, 65 on the cutting edge. But my understanding is that's because they're laminated to a lower carbon steel, so they get the toughness from the steel that they're laminated to.
Yes, it's a brittle, more harder steel on the bottom, and then a big slab of kind of softer, heavier steel on top. Yeah. Or not heavier, but thicker.
Yeah.
Does anybody know what the old LMI chisels were made out of, or what their hardness was? I use those a lot, and I always felt like those had a really good compromise. their workability versus durability. I don't know. Is the hardness the only thing too? Because I don't know. It seems like is there anything beyond that in terms of how we rank a chisel? Because boy, I've gotten some old chisels from yard sales that, I mean, they seem like relatively the same hardness, but they seem like they wind up the edge winds up lasting a little bit longer. I don't know if I'm anthropomorphizing my chisels or not, but
I think there's really something to that, Ian. Certainly, there's all the different types of steel, and they have different characteristics in terms of maybe their brittleness or toughness, or just how sharp an edge you can get with them. So probably the quality of the steel, what the carbon content is of the steel, all those variables would matter, in addition to the hardness. I don't. I know very little about this, but I don't know why. But supposedly in certain blade makers, like old the chains that they use on ship anchors, but these are from like pre 1940. So just like we talk about old guitars, I guess you can talk about old steel being somehow better than new steel. I don't know what the differences would be.
It's funny. Have you seen those guys that get nuts about anvils? Like for whatever reason, that's been in my Instagram feed recently, and they get really crazy about measuring the bounce of a ball bearing on an old anvil.
Yeah, we must have a similar Instagram algorithm, because I got turned on to the anvil videos as well, and it's quite surprising.
Just the difference in the steels and how they respond to having a ball bearing dropped on them by a nerd.
Yes, exactly. Yeah, I must be a nerd because I was fascinated enough to watch the entire thing.
Yeah, I know. And I don't really have call for an anvil much in my life. So, but still, there I was transfixed.
Yeah.
There are some new tool steels in the violin world that are cryogenic, and I bought a couple of them. I haven't used them enough to really understand the differences, but a lot of the violin makers are pretty crazy about it. It's a completely different, I guess, tempering and curing process. But obviously not obviously, but the sweet spot, as I understand it, is you want ability to create an edge effectively, but then to hold an edge. And designing steel that will do both of those is difficult, and that's why the Damascus stuff, folding it together and laminating it, and creating those laminated edges has worked out pretty well. But evidently, this cryogenic stuff is pretty cool.
No pun intended.
Pyro treated A2 steel. You can get some of it in Lee Nielsen stuff. Huh. Well, that's fancy looking. Cool.
So, two resources that I'd like to share with the group on this subject, if you want to dive in deeper, there's a YouTube channel called Blondie Hacks, and yeah, and she's great. She's I think she says she's a hobbyist machinist, but she sure seems like a pro to me. She's got a great YouTube channel, and she goes through everything with not just machining, but tool making of all sorts. And that's I found her videos to be very clear and well thought out in terms of explaining the tempering and annealing and the hardening processes. The other one that I would recommend is there's a new video out on Robbie O'Brien's site. Sorry, I can't remember the person's name, but he goes through plane making, and he's got several lessons that include making the blades for the planes as well. So, and it doesn't hold the record for Robbie's longest course, but it's a long course. It's 11 hours, and but it's extremely thorough, and I've enjoyed it and would recommend it.
Cool.
I've got a few tools that I've made I could share real quick.
Sure.
I've got these violin maker knives, and I just took old plain blades and ground them down to a point, left-handed and right-handed. They're like marking knives. So these are the old plain blades from the 45. They come in different sizes, the Stanley 45.
Watch those toes.
Yeah, and then I was making mends for a while and made a little round bottom block plane for hogging wood off on the inside of the arch. And then I made another tool. This is a Stanley carpet hammer, tack hammer, and heated up on a little coal forge in the backyard and hammered out and put a nice sharp edge on it for hogging off wood in the inside of a mandolin.
Nice.
Are you swinging that? When
You bet.
Yeah.
Yeah, made a S-shaped handle for it. Watch your toes. Yep. It's got a pretty steep angle, so if you're careful, you can hog off some wood pretty quick with it.
Yeah.
David, when you made those violin knives, did you soften the plain blades, or you just ground them into shape in there?
I just ground them down
Yeah.
slowly, kept dipping them in water.
Okay.
And he's got two different sizes, and then right-handed and left-handed. And then I just made a rosewood handle, kind of chiseled out the width of the blade, and then epoxied it inside two pieces, and then glued it together, and just kind of tapered the end a little bit.
So, David, I have a question for you. With those knives, I've always liked where I could take the blade out to sharpen it. But what's your method for sharpening those with the handle, so close to the cutting edge?
So like this one, I've had to cut into the handle a little bit. It's kind of hard to see.
Yeah.
But the other ones are a little bit longer, and I can get them on the edge of a sharpening stone. And I just do it by hand on a stone.
Gotcha.
But I don't know if you can see. Where's the camera? There we go. There's a little bit of a bevel on the bottom here because it can't quite reach.
Yeah, I see it.
Stone. But the tip's mostly what I use.
Nice. Thanks for sharing those.
Sure.
I don't know how that Blondie Hacks got out of my algorithm. She used to be in my YouTube algorithm all the time, and I watched a lot of her stuff.
Yeah.
I need to get more of that stuff going. I probably got off onto website stuff. Now that's littering my algorithm. Anybody else? Anybody else heating up steel? Burning their elbows? I'm kind of excited to do this.
It's a lot of fun because it doesn't take very long. It's not complicated, and the cost of failure is really very low, except for the touching the to your tongue part.
Yeah,
That takes a little getting used to. You got to build up some calluses.
absolutely. Have you ever messed around with file making or anything like that? Like,
I have not. No.
what about you, James? You ever messed around with that?
No. Oh, Instagram, there's a handmade rasp uh, manufacturer. So I've seen some interesting videos, but I've never tried anything like it.
Any guess on how those would have been produced back in the day? Would they have like heated them up and pressed them into something, or
Files or the rasps?
files?
I don't know how the teeth were cut on. Um, the the rasps are done with a hammer and a point to turn up like a little tongue.
Yeah.
I think the files may have been done similar way with a straight edge. Is that sorry, Thomas, I cut you off.
No, it did. The old rasps were hand stitched, so they're like tapped out. Each tooth is like tapped out.
Yeah,
and it creates like a random pattern, so that your cut is smoother because it's done by a person.
I bet those guys drank a lot when they got off work.
Oh yeah.
They're like, oh my God, I gotta get out of here. Let's go watch some soccer and get drunk.
My customer is one of those people. He works for the people that make these. Is Barco. Works for Barco. So he does he kind of does that. Not hand stitching rasp, but yeah.
You know, the guy that I did my apprenticeship with, he had this crazy fret file that was like, it was so amazing. Like the cut on it was it was a tooth file. It wasn't a diamond file. And it was so smooth. You barely had to polish when you got done with it. I don't know if he had eroded it into that state or if there was a better caliber of fret file that had predated my time on guitar repair. But that's always been kind of a white whale for me, is that old fret file. It was fast too. It was fast and it was clean. Very little polishing afterwards. What do you think, Michael? Should we start calling on people?
Yes.
Okay. Let's see who we got here. Who do we got here? Now everybody's got their cameras off. They figured me out. I can't call on anybody. Well, if you have a question for anybody, you can put it in the chat. Michael, how's your building going? Where are you at with your process?
I got one guitar that's just curing now that I'll be starting to put together next week, and a couple others underway. So,
Are you a batch? Or are you one at a time?
in my mind, I'm one at a time. In reality, I'm batch building because, I'm usually behind, and so I'm always starting guitars more than one at a time.
Like somebody calls and, hey, I'm just checking in, and then you go out.
Hey, when are we going to start that build? Like,
You go out. I'm on it, and you bend some wood, and then you move on to something else.
next week. So
I'm not how repair work got done in my shop.
It's a little bit of a combination. Like I'll batch make, for example, braces and certain parts, neck blocks, cutaway blocks, things like that. I'll generally, make enough for about 20 guitars. And for me, by the time I go through that 20 and I need to make more, I've completely forgotten how I did it the first time. So I need to go back and kind of reinvent the wheel, so to speak. So, and sometimes my future self is smarter and more efficient than my past self, and sometimes it's the reverse.
Yeah.
I find that whenever I batch produce a lot of parts, by the time I get to use them, I've changed, where I was going to use them. They're not current anymore. I'm just like, why did I make so many that I do things a different way now?
Yeah.
It's happened more than once. So
You
whenever I
find
make
yourself
a part,
batching,
I make a few, but not too many, because you never know.
you find yourself batching the things that you is part of the process that you actually enjoy, and you're just like, I think I'll make 100 of these today because I just enjoy it.
I never make 100 of anything. No. Well, with the speaking of tools and stuff, like sometimes it happened to me quite a few times where I had to like make like a one-use little thing where it's pretty easy to put an edge on pretty much everything, but then if you're using it just like once or twice, it doesn't even have to be steel. So I've actually done like punches or like little hole cutters or dowel cutters out of like brass tubing or whatever. If it was just like a couple of cuts, like you had the odd side dot or the odd little shape thing that you wouldn't want to like stay there and like file a steel tube for forever or find the right size. So like even working with softer metals, if it's like a one-use tool, has worked in a pinch quite well. And I was just looking around and I saw this thing, and for the life of me, I do not remember what I made this for. But this is also pretty interesting. If I don't know if you can spotlight, but basically, again, it's a 6 mm brass rod that fits into a pencil soldering iron, where I just ground a flat at the end of it and tapped 2 holes where I can put 2 screws, one on each side, and you can just hold whatever blade it's like it goes into the slot that slides into the holder. And I guess I had to cut something that needed heat. But yeah, it you can get pretty handy with just like a angle grinder and a couple of taps if need be. I think originally I was trying to probably got like some plastic sheeting or something. I don't remember.
Hey, Michael, Kevin's wondering, is there an advantage, disadvantage to building 2 or more guitars at one time, not as a production shop, but more of a hobby builder?
Yeah, I'd say if it's there's pros and cons either way. I mean, one of the advantages of, say, building 2 or 3 guitars at once is as you're, doing the voicing, especially if they're the same model, same guitar, same woods, and you're trying to be consistent, then you can compare them, in stages one to the other, or if they're different models, then you can also use it that way. So you can really kind of A/B test rather than building one guitar and then you go to build the next one and then you're trying to remember, what the the voicing or the tap of the body was like from the last one a couple months ago. In general, I'd say the advantage of doing one at a time is there's definitely a little bit more of a nice flow to the work, at least for me. The guitar tends to progress more quickly, and I enjoy that. I feel like there's a little bit more of a freedom of design and approach, doing things one at a time, where anytime you're doing things in multiples, then at least for me, I immediately start to think about, efficiency. If I'm doing something once, then I'll just kind of push through it to get through it quickly. But if I have to do that thing, 3, 10, 20 times, then I'm usually going to jig up or think about it a little differently. And the only issue with that is you can get a little bit of tunnel vision in terms of, at least I can, in terms of the design and the approach of how to do something. So pros and cons either way.
Ken, any follow-up questions of that? One of the downsides to batching, maybe Michael, you addressed this, but like if you do 10 things and you make 10 mistakes, you got 10 mistakes. So I don't know.
That's true.
Like if you're just doing like hobbyist building, I don't, if you're not in production, other than, and maybe you mentioned this, but other than having one that you try it out on first and then you're like, oh shit, and then you do it better, you do it better on the next guitar. I mean, maybe that's it, and then you just throw the first one away when you're done.
Yeah, that one's a gift for sure.
Yeah.
So I did find, especially when I was learning to do binding and purfling work, that if I had to do a lot of it, my skills progressed more quickly with that type of work, because I really had to kind of figure things out, and just doing it once on one guitar every couple months, I felt like I progressed more slowly that way in terms of learning the skills to do it.
Yeah.
There are a few things, if you do have a complex, say, setup on a tool, whether it, I used to have these binding towers, and it took a while to set them up, and I didn't have a permanent station for them. So in that case, it really made sense to try and do a couple guitars at once, as long as I had that setup going.
Yeah, the muscle memory thing is real. It's interesting. I discovered about learning when I was working on learning Blender was there is something though to forgetting something and then having to work through it again. I tend to it seems like I don't like something can be gone forever if I only learn it once, but if I have to relearn it a second time, it feels like my brain goes, okay, that's important. We're going to need that for later. So sometimes that forgetting and relearning part of it is part of the process too. I don't know if that helps for small batch guitar building, but it was just an observation that I noticed about learning. So what do we got here? Cool. All right. Well, does anybody have anything else they want to say? Hold on a second. Brett Bailey, you ever make your own tools?
This thing.
Ah, that's right. Brett made the plate joining jig.
Let me see if I got a piece around. I might be able to demo it. Mess here.
Your bandwidth is kind of rough right now, though.
Yeah, I'm having problems with that.
Got that Canadian internet going?
Yes. I'll set this up on this table and let's talk about it a bit. All right, so this is a plate joining jig I made.
Oh, hold on. You gotta lock your camera down. Your bandwidth is low.
Oh shit!
It's
I don't
getting
have a way of doing this. I can stand as still as possible.
You know what? Is that still on Looth cuts?
Yeah, it should be. If you want to pull that up.
Yeah, I can pull that up. You want to walk us through this?
Yeah. So that picture there, what I was doing was gluing binding to the side of a fretboard before putting it back on the CNC for further milling. Just one of the ways I found I could use this for. If you flip to, I think it might be like a next picture or so, it'll have like a top.
I don't think we got another picture. We got. I think we only got one picture in here. Did we lose some pictures? I felt like you had more pictures than just one.
If you go to the Bailey Instrumental Instagram, there should be some there.
EY?
Yeah.
Wait a second. You're not mentioned. Is this you? Which one is you?
Second one. Go to the Instagram page.
This one?
Yeah, that third picture there. So that's a plate joining jig I made. It's kind of like a fractal press in a way on the sides, so it adapts to live edge or any weird cutout that you had to do at the bandsaw. There's two Sapele bow clamps, so they're thicker in the middle and thinner on the edges, so that when it gets pressed down, it ends up laying flat. That just keeps the wood down, stops it from being squirrely. And then, yeah, there's eccentric cam clamps on the side. So those squeeze in on the side of the wood and you just turn them lightly and it'll create enough pressure to close that gap up.
No, really cool. And it says Sadowski over here. You made one for Roger, right?
Yes.
Cool. Awesome. Thank you. Michael, you got any questions for Brett about that?
No, it's a nice design. So
Thank you.
yeah.
What do you use? Are you using ropes and wedges? You're a ropes and wedges kind of guy?
I'm not a ropes guy, but I am a wedges guy. So that kind of the way that I do it is because I use hide glue. I have to get it on the jig and clamped really quickly. So I only have three wedges, and then I do it in my go bar deck, and then I just put a go bar right on the center to keep the plates down, and I can get it in there probably in under 30 seconds. So
All right. Well, Max, do you want to pop back in?
what's next time, Max?
Sorry, what?
What's next for the club?
I don't know. I have to go down the list, but we'll figure it out. We'll let people know. It'll be early May, so nice spring episode.
Mm-hmm. Cool.
Well,
everybody, thanks for hanging out for Acoustic Guitar Builders Club. If you could unmute and thank Michael and Max. And if you guys,
thanks everyone.
thank you.
Thanks, fellas.
Thank you. Thank you. If you go into Artisan, there's going to be a contingency there. So make sure you say hi to me. Sometimes I forget to say hi.